Tina slowly. We be working all day long to push us money. We ain't playing no games. Sabatavi, Gani.
Hello, grade 11. I hope that you are good. I'm happy to be with you again. Please, if it's your first time watching this video, please don't forget to subscribe. Please do subscribe and support our page. Hit that button of notification so that you can get every notification when we have a new update. So guys, on the previous video we're doing simplification and introduction of the laws of exponent. Actually, we were revising the exponents that you did in grade 10 and also the surds. So here guys, without wasting more time, so we are going to simplify this question without use of a calculator. But they don't say without, if they say without use of a calculator, they don't mean take your calculator away from you. You can test this one and see the answer that you want. So for me, I'm going to put 1 wherever I see n. So I'm going to put 1. So if I say 3, we have this power, which is 3 to the power 2 into 1. Because we said that in place of n, I'm going to put 1 plus 1, then times 15 to the power 2 into 1 minus 3 over, then I have 27 to the power, then I put 1 minus 1 times 3 to the power 1 times 5 to the power 2 into 1 minus 4. So the answer that I want here is 15, guys. It's 15. It's cheap now. You can get it from the Spaza shop. Right, let's take this question, guys. Remember, we said, guys, on the previous video that we need the prime factors here. If we solve this, I need the prime factors. So after I get the prime factors, I'm going to multiply the exponents in the brackets. So, and take everything to the top. So if I take everything to the top, the signs of the exponents change. So let's take this one. So guys, do you agree with me when I say 3 is already a prime base? So I'm not going to change 3. So 3 will remain as it is, 2n plus 1 times, then I want the prime basis of 15. So how do you find your prime basis using your calculator? We said you press this composite number that you are given is 15, then you press equal sign, then you press shift, then you go to this button. Then you press this button, guys, fact, which is then your prime factor is 3 times 5. So I'm going to say 3 times 5. So what is your exponent? Your exponent, guys, will remain as 2n minus 3. So I have 2n minus 3. So are we together? And then we divide throughout. So the composite of 27, we all know that, guys, 27 will be what? Will be 3 to the power 3. That's your prime basis of 27. So your exponent was n minus 1. So I'm going to say n minus 1 here times here. Remember, this prime base must remain to 3n times, this is already a prime base, so will remain as 2n minus 4. So this is 4. So now here, guys, which law that I need to apply with these brackets? I need to apply law number 3. Understand? Law number 3 says that this exponent is going to multiply every exponent inside the brackets. So I'm going to keep this one as 3 to 2n plus 1 times. We know that, guys, anything multiplied by 1 remains the same. If I say 1 times 2n is 2n, 1 times negative 3 is negative 3. So I'm going to have 3 to the power. The powers will remain the same. 2n minus 3 times what? Times 5. so the powers will remain the same, which is 2n minus 3 over 3, then 3 times n, it's going to be 3n. Then the most of the learners, they forgot to multiply also this negative 1. Remember, this is your binomial, so this 3 must multiply 2 times outside. So it's going to be 3 times n is 3n, 3 times negative 1 is negative 3, times this one, we're going to keep it as it is, then times 5 to 2n minus 4. Okay, hope we are good, guys. So now, which law I'm going to apply on the numerator and which law I'm going to apply on the denominator? So can you see this is the bases are the same? I'm going to apply law number 1 on the numerator, which with these prime bases, which is 3 and 3. And also here with 3 and 3, I'm going to apply the law number 1. So I just want it to make it easy for you so that you can see. So the bases are the same. Here I'm going to take one base and add the exponent. So I'm going to focus here. So I have 2n plus 1 plus 2n minus 3 times this 5, guys. 2n minus 3 over. Now can you see that the bases are the same? So I'm going to take one base and add the exponent. So it's going to be 3 to 3n minus 3 plus n, hope you are good, times 5 to 2n minus 4. All right, let's simplify the exponents. So if I simplify the exponent, 2n plus 2n will give us 4n. 1 minus 3 will give us minus 2. Then times 5 to 2n minus 3. Then all over. Then what do we have on the denominator? We have 3. So 3n plus n will give us 4n minus 3 times 5 to 2n minus 3. So now I'm going to take everything to the top, which means if I'm taking everything to the top, the signs of the exponent, they are going to change. So, but I'm going to apply law number 2 here. This is law number 2. So the signs of the exponents here are going to change. So what do we have? I'm going to say we have 3, 4n here minus 2. If I take this exponent, the sign must change. So I'm going to have here, guys, the sign here was positive 4n, so it's going to be negative 4n. It was negative 3, so now it's going to be positive 3. Then we go to 5. So as you can see that, guys, we have this base. I'm going to take it. So we have this exponent. The exponents of the numerator, they are not going to change. So I'm taking this exponent. Remember, we have 5 to the power 2 minus 3. So this is not minus 3, actually it was 4. So this one we must put 4 here, guys. This is 4, this is 4, it was 4. So we have a positive 2n. So if I take this positive 2, the sign is going to change to be minus 2. If I take minus 4 up, the sign is going to change to be plus 4. Right. So then we simplify again the exponent. So 4n minus 4n will cancel out. Minus 2 plus 1 will give us 1 times 5 as your base. So 2n minus 2n is going to cancel out. Minus 3 plus 1, minus 3 plus 4 is going to give us 1. So anything raised by 1 remains the same. So we're going to say 3 times 1, 3 times 5 give us 15. This is the answer that we want. So you will show all the steps so that your teacher can see all your steps, guys. You must not omit the steps, but you can omit this one here. When you are here, you can take everything to the top here. You can take everything to the top when you are here, but make sure that you don't confuse yourself. You must be careful when you take everything to the top. That's why you see me, I was simplifying it first so that I will not make the mistakes. So let's go to the next example and see what we have. So the next example, say I'll simplify. Now this is easy, guys. You can use your calculator and check your answer that you want here. So if I say negative 7 to the power 0 plus 8 to the power 2 over 3, we are looking for 5, right? So let me copy this question down. I have negative 7 to the power 0 plus 8 to the power 2 over 3. Now this is easy, guys. I have 0 here, so we know that anything raised to the power 0 is what? It's 1. I have 1 here. Plus, remember, this is your rational exponent. So I have to change this one to make the prime base. So if I change 8, 8 will change to become 2 to the power 3. Understand? And then I close my brackets. Outside I have the rational exponent, which is 2 over 3. Which law that I can apply here? Yes, I hear you that you are saying it's law number 3. Yes, it's law number 3. So I'm going to multiply the exponent. So I have 1 plus, if I say 3 times 2 over 3, so guys, 3 times 2 over 3. So this 3 will cancel out, then you are left with what? With 2. So 2 to the power 2 is 4. So 1 plus 4 is 5. So that's your final answer. Maths is easy, guys. Maths is easy as long as you practice. So let's go to the next one. So we have these guys. They say simplify again without using the calculator. Remember, guys, I will emphasize again. You can check the answer that you want here. I'm going to do it one for the last time. I have 5 to the power x times 10 to the power 2x minus 1 times 2 to the power 4x plus 1 all over 20 to the power 3x. So I'm going to say I'm going to put the fraction 5 to the power 1 times 10 to the power 2 into 1 minus 1, then times by 2 to the power 4 into 1 plus 1. Hope you can see. Then we go down to 20 to the power 3 into 1. We're looking for 1 over 5. Oh, right, let's take it. So this is the question. What do I need first? I need the prime factors. Yes, I see that. So already 5 is already a prime base, so I'm gonna drop it as it is. Times, for the prime factors of 10, we all know that the prime factors of 10, it's what? Is 2 times 5. So it's 2 times 5, right? So your exponent, guys, was what? Was 2x minus 1. So I'm going to put 2x here, minus 1 again. So we can see that 2 is already a prime factor, so it will remain as it is. Over the prime factors of 20. Yes, I hear you that you are saying is 2 times what? Is 5 times what? The prime factors of 20. The prime factors of 20, guys, is 5 times 2 to the power 2. So if you check this 20 equal sign, then you say shift and fact. So it's 2 to the power 2 times 5. So it's 2 to the power 2 times 5. The reason we don't take 4, guys, 4 is not a prime base, so it's not a prime factor. So the exponent here was what? Was 3x. So here we have 3x outside. So which law I'm going to apply with these brackets? I'm going to apply law number 3 again. So if I apply law number 3 says that this exponent is going to multiply every exponent inside. And this exponent is going to multiply every exponent inside. So I'm going to keep this one as it is. Times, then I have 2. So 1 times 2x is 2x. 1 times negative 1 times 5. So 1 times 2x is 2x. 1 times negative 1 is negative 1. Then we keep this one. Okay? So then we are here on the denominator. So 2 times 3x is going to be 6x times 1 times so we are here in 5 to this base. So 1 times 3x is 5 to the power 3x. What do we need to apply on the numerator? Which law we need to apply on the numerator? We need to apply on the numerator, guys, law 1. Can you see here, guys, the bases are the same. So I'm going to take one base and add the exponents. So we see that here also the bases are the same. So I'm going to take one base and add the exponent. So we have 5, then we take this x, and then we have this power, then I say plus 2x minus 1. Right, yes, I see that you are smiling now, because we are going to get the answer that you got. So here I'm going to take this 2, this is 2x minus 1, then we're going to keep this sign again as it is, right, over 2 to the power 6x times 5 to 3x, right? So I'm going to simplify the numerator. So if I say x plus 2x, we get what? 3x. Minus what? Minus 5. Then say times 2, then 2x plus 4x, we get 6x. Minus 1 plus 1, they are going to cancel out. All right. So on the denominator, I have 2 to the power 6x times 5 to 3x. Now, which law you need to apply? I'm going to apply now. Immediately after I simplify the numerator, the exponents of the numerator and the exponents of the denominator, I'm going to apply law number 2. So I'm going to take everything to the top. So I'm going to apply law 2. So I'm going to take everything to the top. So here I have 5. So this was your exponent, 3x minus 1. Remember, if we take this exponent up, this positive 3x is going to change to become minus 3x. Then times 2, this one, 6x. If we take this 6x up, the sign is going to change to become what? Minus 6x. Understand? So what will happen to 3x and 3x? They are going to cancel out. Now you are left with 5 to minus 1. Okay? So what will happen to 6x and 6x? They are going to cancel out. Then we are left with what? No, we are not left with 1. We are left with what? With 0. So this is 2 times, this is 2 to the power 0. We know that, guys, anything to the power 0 is equals to what? To 1. So now this is the same as 5 to the power negative 1 into 1. Now we know that this exponent tells me that this base is in a wrong position. It must go down to be a denominator. So it's going to be 1 over 5. So that's your final answer. Hope that we are together. Right. So let's move to the next question on simplification. So I have this question, guys. Remember, you can pause the video and try to attempt on your own. I hope that you are good. So you can pause the video and try to attempt on your own. The question says, show that. So we are required now to prove. So it shows that 6 to the power half n times 12 to the power n plus 1 times 27 to the power negative half n over 32 to the power half n is equals to 12. All right. So here, guys, this is the question that we have. Let's take this paper. This is the question that we have. So I'm required to prove that this thing is equals to 12. Now, since I have the equal sign, I'm going to consider this one as my right hand side. So this is your left hand side. So I'm going to take this left hand side and try to prove it to be the same as the right hand side. Okay, this is cheap, guys. Don't panic. Don't panic. Don't panic. So here I'm going to need the prime factors of 6. I'm going to need the prime factors of 12. I'm going to need the prime factors of 27. This is supposed to be 27, not 12 again. This is 27. Let's change it. So this is supposed to be 27, isn't it? So if this is supposed to be 27, I'm going to put 7 here. This is 27, because the question, it was given to be 27 to the power negative half n. All right, let's work it out. So here, guys, what we need to do, I'm going to open the brackets here, then times, I'm going to open another brackets for 12, then I have 27, because we can see that 27 is not a prime base, so I'm going to open another brackets for 27. We can see that 32 is not a prime base. I'm going to open another bracket. So we have the exponents. I'm going to keep the exponents. We have half n. Here we have n plus 1. Here we have negative half n. Now then here we have half n. So now talk to me. What are the prime factors of 6? Yes, is 2 and a 3. The prime factors of 12 is 2 to the power 2 and 3. The prime factors of 27 is 3 to the power 3. Yes. You are genius, guys. The prime factors of 32 is 2 to the power 5. Yes. Can you see this is easy, guys? This is easy. So which law that I need to apply here? So I'm going to apply law number 3. Can you see that your laws are very important when you are doing this? So law number 2, we all know what law number 2 says. So I'm going to say here, the power here is 1 and 1. So I'm going to get 2 to the power 1 over 2n times 3 to the power 1 over 2n times here, I'm going to say 2 times n is 2n, 2 times 1 is 2 times 3. So we have the power 1 here, which is n plus 1. Then we have 3. So here is going to be negative 3 over 2n all over. So what do we have here on the denominator? So I'm going to have 2. This 5 is going to multiply this half n. It's going to be 5 over 2n. Which law I need to apply on the numerator? Yes, it's law number 1. When the bases are the same, you add the exponent. So where do we see the bases are the same? Now we see this one and this one. So I'm going to take one base and add the exponent. So I have half n plus 2n plus 2. Then times, then I see the bases here are the same again. So I have 3 to 1 over 2n plus n plus 1 minus 3 over 2n, then all over 2 to 5 over 2n. Right, so are we still together? Yes, I hope that you can see. Now I'm going to simplify the numerator. So if I simplify the numerator, half plus 2n, we know that this, we have 1 here. So half plus 2n, we're going to get 5 over 2n plus 2, because we added 2n plus half n, then we get 5 over 2n plus 2 times 3. Remember, I have half plus 1. Half plus 1 will give me 3 over 2n. So this 3 over 2n will cancel this one. So this, we're going to cancel this n. Then you're left with 1. All right. So over 2 to 5 over 2n. Remember, which law we need to apply if we hide 3? The basis here for 2 is the same. So I'm going to take one base and subtract the what? The exponent. So I'm going to take everything to the top. So I have 2 as your base, then this is power 5 over 2n plus 2. Remember, this exponent, its sign is going to change to become negative 5 over 2n. So times this 3 to the power 1. Remember, we are required to prove this is equals to 12. So now, can you see 5 over 2n will cancel 5 over 2n. Now you are left with 2 to the power 2 times 3. So we all know that 2 to the power 2 will give us 4 times 3. So 4 times 3 will give us 12. Yes! Then we are happy because this is equals to what? To 12. Now we can conclude that the left hand side is equal to the right hand side. So are we together? This was easy. So let's do the last question for this, and then we are going to continue with the others, with other questions on the next video. Right. So guys, what do we have on this? We have this one here. They say simplify this. So they say simplify without use of a calculator. So I'm going to take number 1. Remember guys, you can pause the video and try to attempt on your own. So I'm going to take number 1. Then we are going to continue with number 2 and number 3 on the next video. Right. So number 1 guys, remember you can test again on your calculator and see the answer that you want. So if I press the fraction here, I have 8, then I put 1 minus 1. I'm going to use this times 3 to the power negative 1 minus 1. Remember, in place of x I put 1 over, go down, yes, 1 over 4 to the power negative 1 times 6 to the power 1 minus 3 times 9 to the power 1 minus 1. So I'm looking for my answer supposed to be 1. Okay, this is easy. So I'm going to copy this question down. I know that you are close to the final answer because you stopped the video and tried to attempt it on your own. Now I know that you are close to the final answer, so bear with me. So I'm going to move slow so that we can all be in the same page, on the same page. So I have 1 over 4 minus x times 6x minus 3 times 9, 1 minus x. Right. So I need the prime factors first, guys, here. So if I need the prime factors here, I need the prime factors of what? Of 8. I need the prime factors of 6 and 9 and the 4. But the first thing that I need to do here, I need to write this one as a what? As a negative exponent in order for me to make the prime bases to be the same. So I'm going to apply the definitions of exponents. So exponents definitions. So here I'm going to say 2 to the power 3. So then you have x minus 1 outside times 3 minus x minus 1, right? So over, I'm going to write this one, guys, as a negative exponent. So it's going to be 4 minus 1, understand? So then we have negative x times the prime factors of 6 is 2 times 3. Then I have outside x minus 3. Then times the prime factors of 9 is 3 to the power 2. Then I have 1 minus x. Okay, now this is easy, this is cheap. So which law I need to apply here? Yes, it's law number 3. So I'm going to have 3 times x is 3x, 3 times minus 1 is minus 3, times here, this is 3 minus x minus 1. Remember, I have to change this one to make the composite base. I mean to make the prime base. So here I'm going to say 2. Okay, I just want to break it down, guys, for you. Remember, we were having 1 over 4. 1 over 4 is the same as 2 to the power 2. So if I make this one, I write this as a negative exponent, it's the same as 2 to the power negative 2. So I'm going to change this one to be 2 to the power negative 2. Then outside we have negative x times which law that we need to apply again here is law number 3. So I'm going to have 2, then we have 1 here. 1 times x is x, 1 times negative 3 is negative 3 times 3. So 1 times x is going to get the same thing times. So we're going to say 3, then 2 times 1 is 2, 2 times negative x is negative 2x. Okay, so far so good. All right, so we have 2, then 3x here minus 3. Okay, this is not clear. We have 2 to 3x minus 3 times 3 minus x minus 1 over, then we have this base, negative 2 times negative x, we get positive 2x, because the negative times negative is positive, times 2x minus 3. Don't forget our answer, guys, was negative 1. So times 3x minus 3 here, times 3 to the power 2 minus 2x, this one. So which law that we need to apply on the denominator? We need to apply law number 1. So because we can see here that the bases are the same, so I'm going to take one base and add the exponent. So I'm going to have 2, so 2x plus x, we're gonna get 3x, so minus minus 3 times, so here again with 3, the bases are the same, so I'm going to take one base and add the exponent. So x minus 2x, what do we get? It's minus x. Minus 3 plus 2, we get minus 1. So on top we have 2x, 2 to the power 3x minus 3 times 3 to minus x minus 1. So I'm going to take everything to the top now. Remember, if we take everything to the top, signs of the exponents change. Don't forget that. So I'm going to say 2. Remember here we already have 3x minus 3. So if I take this to the top, the signs must change. So I was having here positive 3x, now it's going to be negative 3x. I was having negative 3, now it's going to be positive 3. So are we together? Now we have again 3 minus x minus 1. So remember, we were having here, guys, negative x. So if we take negative x on top, the sign is going to change to be plus x. We're having negative 1, the sign is going to change to be plus 1. All right. So what will happen to 3x and the 3x? They are going to cancel out. What will happen to negative 3 and positive 3? They are going to cancel out. Then we are left with 2 to the power 0 times. So then we go to this base. What will happen to negative x and positive x? They are going to cancel out. Negative 1 and positive 1, they are going to cancel out. Then we are left with 3 to the power 0. Wow. Anything, guys, raised to the power 0 give us what? 1. So we now we can see this is 1. This is 1. So 1 times 1, it's 1. That's your final answer. Okay? So, guys, this is your final answer. Remember, we said that, guys, you can take this one and try to do it on your own. We are going to do the next questions on the next video. So please, here, if you didn't subscribe, please don't forget to subscribe and hit the button of notification so that you can get any updates when we have a new updates about our channel and when we post new videos, so that you will be updated. So here, guys, once you see the sign plus or minus between the bases, one method that you need to do is to take out the common factor, and you will be able to solve it or to simplify it. Thank you for watching. See you on the next video.